In this lesson, we're looking at inverse trigonometric functions. And you have used inverse trig functions in your calculator before in the first lesson of this chapter when you were solving a right triangle and you only knew the sides and you had to use the inverse trig function in your calculator in order to find the angle. Well, now we're also going to be graphing these inverse sine functions and inverse cosine functions. But in order to do that, realize that way back in chapter 1 we talked about how if a function passes the horizontal line test, then it will have an inverse function. Well, due to the periodic nature of these sine and cosine graphs, it should be obvious to you that you can't take the inverse function of the entire sine graph. So that's why we have to restrict the domain. So if you consider, for example, this cosine graph, I want to restrict the domain in such a manner that I'm still using my full range. So notice how the range of this graph is going from -1 to +1. I want to restrict my domain so that I'm starting at either my minimum or my maximum and ending at the other before there's any failure of the horizontal line test. So in this cosine graph, you see that we're restricting the domain from 0 to pi. If this had been a sine graph, well, remember what it looks like. It goes like this. And so if I'm trying to go from my maximum to minimum in as concise a manner as possible, I'm going from here to here, which is actually, if you'll see in your notes, from -pi/2 to +pi/2. So when we're looking at this in the unit circle, realize that this 3pi/2 is equivalent to -pi/2. So when we're using the unit circle to find the arc sine of a value, as it is also notated, we'll be using the right half of the circle. As I mentioned before, we restrict the cosine's domain to 0 to pi in order to find its inverse function, which means when we're looking at the unit circle, we're looking at the top half. Now, we haven't talked about graphing the tangent function, so we're not going to be graphing the inverse tangent function, but we will be calculating inverse tangent values, and when we do so, we'll be looking at the right half. Okay, so cosine is top half, sine and tangent are right half. Here we go. I apologize that when I printed this, the copy quality wasn't so great. It looks better on your notes than it probably does on mine. Hopefully you'll be able to follow along. In example 1, part A, I'm finding the arc sine of radical 3/2. So remember that the sine is the y-coordinate over the r, and in the unit circle, the r is always 1. So what you're looking for is a y-coordinate. So in the unit circle, we're looking for a y-coordinate on the right half that is positive radical 3/2, and it's right here at pi/3, equivalent to 60 degrees. Either of those answers is correct. The instructions didn't specify whether we wanted the answer in radians or degrees. Eventually, we'll probably be giving the answer in only radians when we are solving trigonometric equations next chapter. In part B, I'm trying to find the inverse sine of -2 pi. So I'm looking for a y-coordinate on the right half of my unit circle of -2 pi. And of course, that doesn't happen. So it does not exist. In part C, we're looking for an arc sine of -1, so I want a y-coordinate of -1. In this, right half of the grid. So it's down here at 270, equivalent to 3 pi over 2. But remember that I'm only interested in negative pi over 2 to positive pi over 2. So I have to think in terms of what is 3 pi over 2 equivalent to that falls within these values. So think in terms of coterminal. I'm going to subtract away 2 pi from this. So 3 pi over 2 minus 4 pi over 2 is negative pi over 2, which is equivalent to negative 90 degrees. Make sure that you realize these are the correct answer, not these, because these don't fall within our acceptable domain. These do. Now we're finding the inverse cosine of negative radical 3 over 2. So since this is cosine, we're looking for an x-coordinate of negative radical 3 over 2. And because this is cosine, remember we're looking at the top half of the grid now. So we want an x-coordinate of negative radical 3 over 2, which is here at 5 pi over 6, which is equivalent to 150 degrees. Part B, I'm finding the arc cosine of 2.5, which means I'm looking for an x-coordinate of 2.5, and on my unit circle, that does not exist. Part C, we're looking for an x-coordinate of negative 1/2. So on this top half of the grid, where do I see an x-coordinate of negative 1/2? I see it here at 2 pi over 3, which is equivalent to 120. In example 3, we're taking arctangents. This is a little bit more complicated because what we're looking for, since we're finding the arctangent of negative radical 3 over 3, we're looking for the y over x to be negative radical 3 over 3. Now, remember that this unit circle, its values go from negative 1 to positive 1. Those are the maximum values you're going to see here. So if you're looking for a radical 3, or you're looking for a 3, you're going to look forever, and you might make the mistake of thinking it does not exist. I will tell you it does. Okay, so something that we want to realize initially is that negative radical 3 over 3 results from a simplification of negative 1 over radical 3. All right, so a 1 maybe I'll find on my unit circle, but a radical 3 I still won't. That's a value that's greater than 1. So look at your unit circle and notice that there are a lot of values over 2. And that if I had 1 over 2 over negative radical 3 over 2, that those 2's would cancel out, and I'd simplify my radical and end up getting this value. So now we have something to look for. We're looking for a y-coordinate and x-coordinate of 1/2 and radical 3 over 2, respectively, where one of them is negative. Okay, so, and make sure that you realize where you're looking for it. You're looking for it in the right half of the grid. Okay, so I'm looking for a y of 1/2. So not here, not here, not here. Okay, so there's my 1/2, but I needed one of these to be negative, and that's not the case here. It is the case here. All right, so my answer is my angle on the unit circle is 11 pi over 6, but I would hope that you'd realize that's not your answer. It's not within the accepted domain. Okay, so let's start with the 11 pi over 6. And then realize that the angle I actually want is coterminal with that, so I'm going to subtract 2 pi from it, but in order to subtract that I want a common denominator, so it's negative pi over 6, which is equivalent to negative 30 degrees. Okay, so again, be very, very careful about keeping in mind the accepted domain for the sine and the tangent. The cosine, you don't have a problem with that because your domain is 0 to pi, and 0 to pi are values that are on your unit circle. The accepted domain for sine and tangent is negative pi over 2, and you don't visually see a negative pi over 2, and you have to start making the connection that this 3 pi over 2 is equivalent to negative pi over 2. In part B, we're finding the inverse tangent of negative 1. So again, we're looking for a y over x that will equal negative 1. So what I'd like you to realize is that the x and y coordinates are going to be the same number, basically, but one of them is going to be negative. All right, so nowhere in this quadrant am I going to find what I'm looking for. These aren't the same value. These, radical 2 over 2, radical 2 over 2, same value, one positive, one negative. That's what I'm looking for. So that's at 7 pi over 4. But I remember 7 pi over 4 isn't within my accepted domain, so I have to find the angle that's coterminal with it. So I'm subtracting 2 pi and getting negative pi over 4, and that's equivalent to negative 45 degrees. Next, we're looking at graphing these functions. And I apologize again for the copy quality on my paper. Yours looks much better. Hopefully it's not as crumbled as mine. Okay, so we talked about how we restricted the domain of the sine and cosine graphs to, in the sine, we restricted it to negative pi over 2 to positive pi over 2. So we said that we restricted the domain of the sine graph, so then that should make sense that that is the range of your inverse graph. Similarly, we talked about how the range of our original graphs went from negative 1 to positive 1, so it should make sense that that is now the domain. Similar idea with the cosine graph. Something that I hope will help is remember that the inverse of any function is the reflection of the original graph over the line y equals x. Another thing to consider is, for example, if I have the equation y equals arc cosine x, that equation is equivalent to this one. So that might be another strategy to take into consideration as your graph. I think a valuable strategy for us to consider in graphing this equation is that it is the inverse of, well, let's figure it out. In order to take the inverse of this graph, remember you switch the x's and y's. So x would equal the arc cosine of 2y. And then I would want to get y by itself. Well, remember this equation is equivalent to the cosine of x equals 2y. So if I get y by itself, then I have y equals 1/2 the cosine of x. Well, what would this graph be passing through? Well, it would go through 0, 1/2. It would have a period of 2 pi, so I know that it would go through 2 pi, 1/2. I know that halfway between these two would be pi, -1/2. And that halfway between these minimums and maximums would be x-intercepts. So it would pass through pi over 2, 0, and 3 pi over 2, 0. Now I know that the inverse of a graph switches the x and y coordinates around. So let's switch these around. I end up with 1/2, 0. 1/2, 2 pi is outside of our accepted domain. So I'm not going to graph that one. It'll pass through -1/2. This pi over 2, 0 will become 0, pi over 2. And so what I'm going to do on my grid is plot these points and see if that gives us enough to make a curve out of it. So every 4 boxes on my x-axis I've got representing 1 and -1. I'm going to make every 4 boxes on my y-axis also represent pi. So I'm going to plot these points and then see if that gives us enough to make the full curve. So -1/2, 0, or I'm sorry, 1/2, 0, -1/2, pi, and 0, pi over 2. And before I connect the dots, I want to make sure that I'm kind of staying true to what this graph should look like. So I refer back to this schematic. Okay, so notice the general shape of it. And that's it. Don't put arrows, because remember, we had to restrict the domain of our original graph in order to take the inverse of it. So no arrows. And that's it. Okay, so if you consider taking the inverse of it so that you can identify a few key points and then plot the appropriate ones on your graph, you should be in good shape. Let's do the same thing with example 4a. This, let's take the inverse of it. So x will equal arc sine of 3y. Now I want to get y by itself. So I'm going to use the definition of arc sine to do that. That means I'm writing the equation sine of x equals 3y. And I divide this whole equation by 3 and I get 1/3 sine of x equals y. So let's remember what the sine graph looks like. It passes through 0, 0. It would recycle itself at 2 pi, so it would also have a point at 2 pi, 0, and hopefully based on what you saw over here, you realize we're not going to be plotting the inverse of that point because it's outside of our accepted domain. Okay, but we're going to use it to remember where the rest of the points are going to be. We know that halfway between this starting point and ending point of our usual graph, we have another x-intercept. Let's also consider -2 pi, 0. Again, we know we're not going to use it, but we know that halfway between it and 0 is -pi, 0, And we also know that positive pi, comma 0. Again, oh my goodness, all these points that we can't use. We know those are outside of our accepted domain. But we use them because we remember that halfway between this intercept and the positive one is our maximum, which is going to be at pi over 2 comma 1/3. And our minimum will be at negative pi over 2 comma negative 1/3. And these are values that we can use when we take the inverse. So we're going to switch these points around. 0, 0 is still a good point. I can't use any of these that are outside of my accepted domain of negative pi over 2 to positive pi over 2. I'm going to switch these two guys around because they're good. I have 1/3 comma pi over 2 and negative 1/3 comma negative pi over 2. And let's see how I'm going to break up my axes. I'm going to break up my my x-axis into this being 1 and 1, 2, 3, this being negative 1, so every 3 spaces. My y-axis, I'm going to break it up the same way I did before, with every 4 boxes representing 1 pi. And here's my 3 points. 0, 0, 1/3 comma pi over 2, and negative 1/3 at negative pi over 2. Again, still getting used to what these graphs look like, so I refer back to my notes to see what the graph is supposed to be shaped like. And it looks like that. Again, no arrows.